Hello, it's Ilkka Tengvall here again. Today I'm gonna tell you about how we implemented GitOps in one of the software projects I'm involved with. And we use the GitOps to create development, staging and production environments for this fever map application in OpenShift Online. I also show you how this can be controlling several different sites, not just only this one site. Okay, so let's get started. This is about the blog I wrote. I thought that why not share the story because many of the clients have been asking how to control secrets when you provision stuff into OpenShift. They also want to know how to control the GitOps basics, that how do you control what changes went in and how do you do audit logging, that who did what and when did that happen. So let's look a bit into this blog. In a video I'll show a little bit what's behind this blog. So this project, first of all, is this fever map. It could be utilized by, for example, officials in different countries tracking how some flu is spreading in their country. It has this application where people can track their data, create actually this is now in Finnish, let me change it. It's how to enter their data about fever and show it on the map, that how it's spreading. But that's about the application. Let's not go into application today. This is about how to do GitOps for such application. So the application, first of all, is this, let's say, microservice kind of cloud native application that consists of several different components, like database. And database requires storage, which is not visible in this picture. Then there is this front-end application, there is this API application, then there is push API application, which sends the notifications to mobiles, and then there is Jenkins to control the pipelines, the build of all this stuff, which happens in the OpenShift. And all this stuff is coming from, it's hosted at GitLab. You can see the address in here, it's in the blog as well. And all this Ansible stuff I'm talking today about is hosted at the GitLab. You can have a look at it at any time. And copy, you're welcome to copy and use anything in here to your own purposes, and please provide back the contributions as enhancements here if you find something. Okay, so what do we want to control with this GitOps? So in this case, like I mentioned, the secrets. We want to make sure that secrets stay as secrets. So for example, Google API keys or SSL certificates or whatever there might be, different API keys that we don't want to spread around. Even though all the code is in Git, of course there are certain secrets you don't want to spread. And we want to minimize the amount of secrets that are being kept as secrets, so we only encrypt things like the above mentioned, like previously mentioned, the keys and certificates and such. Everything else is open, and we encrypt them using the Ansible vault in here. I'll show you later how it goes. The end result is, in this box, like I said, I can create such environment by this one single command. It's really, really powerful now that everything is in Ansible. Okay, so let's go a little bit to see what kind of environments we have for this. So we have, in this example, we have 5 different environments. We have this OpenShift Online version, which is actually in here. So this is the real live OpenShift Online environment. We can see how, for example, fever map application is doing here, the CPUs and memories and such. So this is one of the environments. Then we have, so in OpenShift we have development environment where we can trash at any time and we can rebuild with Ansible and make it follow whichever Git branch we want. This Ansible takes it as a parameter, the Git branch. So if developer wants to develop certain feature, they can branch the code, tell Ansible to build them an environment, and it would be built within minutes. Then we have the staging environment, which is actually kind of the center of it all, that it has the Jenkins pipelines and whatnot. It does these builds, it does releases, it pushes containers into Quay for security analysis and such. And then we have this production environment, which then just runs the outputs of this staging, so we don't want to build anything in here anymore. And by the way, this dev is similar to production, except that it has the build mechanism as well set up. And then I have totally different cluster where I kind of test and verify and toggle these OpenShift components around here, which is my test cluster called Konttikoulu, which means container school in Finnish. There's a Finnish lesson for you there. And there I have staging and dev environment. And all this is now visible here if you want to go and see. Here, you can see the inventories I use, staging, production, dev, and corresponding variables for those. For example, Konttikoulu staging. This is how it's been defined. But let's go forward. So let's look at the Ansible. First of all, these secrets, how they are. How do we handle secrets? This is very often asked question by the customers. So let's have a look at what the secrets look like in this case. For example, I have these variables for, like I said, for these different environments. All the code is common, but we just want to differentiate variables like your web address or API address or database password or whatever that might be, which is kind of site specific. We put them into different variables. It's also sizing that if we look at the scale of things, that for example here we have just one container of each running at staging. If we go to production, then we already have two containers, and then we have autoscaler on. We don't need autoscaler in staging environment, so that's just fine to leave it off there. So such differences you can put into group variables. If we look, for example, staging here, we can see the replica count is 1. Actually, we don't need push API in the staging. We have this kind of URL for the site. Then we have the branch where, the Git repository is set up like this for the staging. And if we look, for example, for the production, you can see we have less stuff in here because we don't need, for example, the URLs for code. We don't build anything in here. And we have different replica sets. We have maximum of 6, for example, at the moment. We have the trigger for CPU here. So a little bit different variables for different environments. And this is now the stuff what you do in the GitOps, that you want to keep the configuration of the environment in Git and version control, so you know exactly what happened and when and who changed what. So now, for example, if I would increase the replica count, I would come into Git, create a branch for my new change, whatever issue I have. I would create a branch for that. For staging environment, I would go and I would change the variables in here, run it against the staging and see if it works, commit the code into that branch. And once I see from staging that okay, it seems to be running fine, I can test it also in my other OpenShift environment here. Okay, it seems to be working fine, and then I'm ready to do a pull request, like in GitOps you do. So then you would do pull request to the master branch, and then somebody would actually, if I look at our pull requests, they are called merge requests here in GitLab. So if you look at the merge request, somebody would review it and then accept it, and then it would go to master. And once it's in the master branch, then I would run the same stuff against the production environment, and it would just push the code as such. I do not go into the OpenShift and tweak those settings manually. I give them to Ansible, so Ansible both sets them, and then it also makes sure that all the previous settings are also in place. If someone else went directly to OpenShift to change them, Ansible would force them to be back to the version what's in Git. Okay, so this is a little bit about GitOps and the behaviors in there. So that's the part we have. I showed you now the environments, and I showed you the variables, and let's look at the secrets. Like here is a list of secrets that we use. Different kind of keys, tokens and such. And let's look how the secrets now go. Even though this is an open source project, I don't want everyone to see our secrets, of course. That's why they're called secrets. So let's look at the production environment. For example, here in production, I have, here's actually the tree of all that code. If I go to the group vars, maybe you see it better in here, I go to production, And I have two files in here. I have the main.yaml and I have the vault. And the vault is the place for the secrets. And let's look what it looks like. So this is, now you will see all our secrets, including the keys and whatnot. Please don't spread them. Look at this. There they are. How does it look like? Is it nice? It looks nice. It's all encrypted. So it doesn't matter you see them. You don't actually get to any of our secrets. This is just encrypted stuff. And you can see what I have encrypted in there. For example, I have this Red Hat.io pull token. So I have the same variable default with vault prefix. And this value is now encrypted in this secret here somewhere. So it's safe to store them now in Git. So I'm confident enough that I can, for this project, we can put them even in the public Git. And okay, so that's about the secrets. So this is something that the secret file actually looks like inside. It's just full of this kind of key value pairs, the secrets, and then we encrypt it. And then, of course, in your organizations, you control who has the decryption key for these secrets, who gets to edit these secret files or read these secret files. So you want to control them so they keep it remains as a secret. Maybe you have different like sites, for example, in this development site, you could give developers some really easy secret or not even encrypt them at all because it's just development if it's internal. Then when you go to staging, developers would not anymore have the key for the secrets in staging, and definitely for the production, only few ops guys have the secret to change the secrets in have the key to change the secrets in production. So this is how you control the secrets, such as the keys and certificates in such an environment in GitOps. This is one way, of course. There are other ways also, but this is really handy way using Ansible. Okay, we went through the site variables. Here you can see some differences between them. Then if we look at the roles, how is this Ansible done? What does it look like when I define some applications? So first of all, these group vars were about the site-specific variables. They could be also host vars. I named them into group vars. Then if we look at the actual roles, so all those components are now listed here separately, and they follow the Ansible Galaxy way of doing things, the Ansible best practices. So I just used Ansible Galaxy init role, and it creates me all this stuff. And then I start to fill the automation in here. This is what the Ansible looks like. So first of all, this sets New Relic stuff into the config map or secrets. It sets image streams where to get the images from. And you see everything here uses this K8s Kubernetes Ansible model. And I made a decision here that I want to keep all the config in one file, so I don't need to poke around between different files while looking at this stuff and developing this stuff. The other option would be not to have the YAML in here, but put them in the separate template and just keep running them from the Ansible. But then everything I would need to check, I would need to go to different files to check it and so on. So I'd rather keep them here in one file. So it becomes a bit longer, but I like the simplicity of it. It's in one file. End result would be the same. Then I define here, for example, the build configs. And one thing here is now important, that this makes a difference now. When app build, I do in Ansible that in staging environment, this app build is set to true, and in production environment, it's set to false. So that's why we don't get any of the app build things done in production. It still remains in the same code. It's just skipped in the production. And then you do different kind of lot of things here. This is pretty much Kubernetes YAML. What's in here, just put into Ansible K8s model format. Okay, so here we even use this Let's Encrypt plugin to create certificates for all the services. Okay, that's what it looks like. Let's get back. And I know one more thing. I want to mention these defaults. So every role then has these defaults that you can just take this role and run it independently somewhere. It should work having these variables set. It has some dummy variables in here. And of course, for your side, you want to replace these with the proper variables. For example, these these network addresses, or the scaling factors, or replica counts, or memory amounts, or such. These are just some sane defaults in here. And in your environment, should you create a new environment, you would go to your environment config and override those variables in here. Like you see, we have different domains for this same application here in our production site. Whereas if you look at my test production site, it only has a single different URL. This is an example how you override these things in these site-specific files. Okay, let's look at the playbook then, how it really goes. Let's go to the beef of it. So this is just the building blocks of it, and let's look at the fevermap.yaml. So this is now the playbook that sets any of these above previously mentioned sites. So here I have set up fevermap, and it includes role. It creates the projects, but in many cases I don't want to delete the project, so I have a variable here saying that please don't delete the projects and or create them. So it just doesn't manage the projects at all. If I start from scratch for the first time, I have it, but then I set this to false. Then it includes all different things. First it sets the secrets, database, the API, application, front-end application, push API. Then it sets the pipelines, and note that all this pipeline stuff of course doesn't exist in production, so we had the variable for that. And then we do certbot thing. This is another side project I created during some evenings to get SSL certificates automated in OpenShift. Then okay, yeah, that's it. So that's the playbook. It's really simple, this playbook. So mainly to use such thing, if you would give this in hands of your developer, they would actually don't need to know anything about it. You would just set up some sane variables for your dev site, this one, and tell developer to run it. Or better yet, let's go to see the Tower part of it. So now I have all this stuff also in Tower. So like I said, let's see how it looks at the production, Conticolor production. This is what it looks like, the application in here. And if I go to this tab, it actually should answer with the front page of the application, like it does. It has all the SSL certs in place and such. I actually created this just 20 minutes ago. So let's go here. Let's just ruin that environment. Let's take it apart. So I go to my view here, and let's just delete that environment. Where was it now? Here, delete. Let's run this delete job. Make sure it's Conticolor, not the production. I could put here tag, for example, API, so it would actually just do the API parts. But let's just get them all out of the cloud. Ka-chunk, here it goes. State is absent, it's predefined in here. Now your developer could empty the previous development environment. In this case it's production, but let's say that this is also my test cluster, so this is not the real production. So the same would work for the developers. So first of all, it went to Git and it pulled all this Ansible code, so we know that we are running the latest master. And now it goes and deletes that stuff. If we go into here, you can see that things start to disappear. Already database disappeared, now went the API, and soon the fevermap application and such. You can see here it's skipping some parts because we are not doing the builds, and this is kind of production, so it's skipping those parts in this case, like defined in Ansible. And now from here you can see that who did it. If you look at the log from Tower, you can see that it was me who launched it. This was the playbook, and then it shows the time when I was running it, and it actually shows the revision of the playbook from Git as well. Okay, it's done now. The project should be empty, like it is. So I still have staging here. I don't have anything in production. Let's go to production. Let's do the contract. Let's put it back. So let's start from scratch. Now I could have a variable here asking that which branch do you want to follow if this was a development environment. But let's just, it would be another question here that, for example, job tags or Git branch or something. Let's just put it together really quick here. I'm not doing any magic. So I just told it to start to provision it back into OpenShift. And while we look at it that it's doing this stuff, I seem to do some bad habit having the same name for group hosts, doesn't really matter in this case. So now it's provisioning it back into OpenShift, and you see that OpenShift is now receiving all that Cube8s Ansible definitions, and it starts to create the environment. And now all the secrets gets pushed from the encrypted storage from the Git into the OpenShift, which then stores them into etcd to be encrypted locally. So they remain encrypted all the time. That's the secret part. So now this is building totally the site from the scratch, and this is how quickly we could provision new production sites, for example, for this application. If I wanted to provision this into, say, US or Canada or somewhere in Africa or Asia or whatever, what I would do, I would copy this group vars, for example, for production, create a new folder like this, and then just set the domains and such in place and press play. That's all it would take. Of course, setting the secrets, but that's all it would take. Okay, we don't want to actually go into this push API, so I stop it. So now we have the application running again. Let's see. Might be it's not yet up, but let's try. Okay, it seems to be even up. So this is how quickly it sets up everything, and now everything is Git based, everything is stored. All the time they were coming from Git master from our fever map project. I could change the branch, of course, and then let's look at one bit more about this CI/CD, because many customers also ask me about how to do stuff in GitLab regarding OpenShift. So GitLab has its own CI/CD engine, so we actually do stuff. I think Otto has done most of this stuff, so they build locally some containers. We don't use those in this example, but developers get to use them when they do their local stuff. This could be run just anywhere. It doesn't need to be OpenShift. So this builds the containers for local development. And here it actually, for example, calls the OpenShift Jenkins to do the releases if somebody commits a new version tag. And Jenkins is set to follow this this fever map staging is set to follow the master branch of fever map. So if anybody commits anything, it will build new application and such. But that doesn't require the GitOps. The GitOps part is now managing how the application is set up in the OpenShift, not what happens inside the application. So this GitOps part is now for this OpenShift part specifically in here. And what it would require, we don't have actually enabled the automation for the GitLab, but I believe this is all it would take to put it into GitLab. So if anybody commits to master branch into directory OpenShift Ansible, it would then run it to staging, and it would run it to production. That's it. GitLab would do it. That would be totally automated GitOps. In our case, this part is still missing, mainly because I haven't ensured myself that whether GitLab keeps secrets nicely or not. But once we get that answered, then I could just add this in place, and we would have fully automated GitOps. So maybe this gave you some tools how to consider things, how to do GitOps one way. Of course, there are different ways. I recommend you heavily to look at the Argo CD, look at the Flux project. Those are good ones also. In this case, then Argo CD doesn't work because we are not admins, cluster admins in OpenShift online here, so we cannot actually use it. So that's why we had to come up with something else. And also, I didn't want to have external dependency to yet another tools. I wanted to keep it simple. That's why it's all in Git, and it would work from the GitLab CI. But anyhow, there are different purposes for different tools, and this was our purpose. And if you need such, here's a good example for you. And like always, if you find enhancements, please contribute them back. They are always welcome. Okay, thank you. Bye.